if you look at number systems, you have the whole numbers and the natural numbers and the irrational numbers. Do you remember what a rational number is? Anybody? Okay, fantastic. It's fraction. Any number you can make a fraction is a rational number. So we're going to solve equations with lots of fractions in them. We're going to have to find common denominators. We're going to have to do all that stuff. Okay? So hopefully we can make it, the techniques we use make it easier. So something like how would you solve an equation like this? If that's a rational equation of the most basic kind, all 40.
What is that next to the?
What?
What is that next to the?
D minus 33.
Oh, because it's on the top.
Yeah. I try not to slam my markers on the board, so I have to write lightly, but as a consequence, sometimes my pen jumps off the board just enough to not write, and then I have to rewrite it. Okay. So that is a rational equation. Do you have any idea how to solve it?
Multiply
By?
3
By what?
over to 35.
Not 33. This is an entire phrase. So you're going to multiply by the entire thing. Yeah. So always take the entire denominator out, if you can. Okay. Those will cancel. So you have, you can distribute that if you want, you don't have to. And at this point now it's a function or an equation that you solve similar to many of them. Okay, never mind. You solve something like that a lot of times. How many do you want to distribute? Several? Fine. You don't have to. It adds a step, so you can divide by 45 straight from here. Just faster, easier. Those still cancel because we have divided and multiplied. So, whatever that is. Anybody?
It's like
37.78.
Yeah.
Okay, so at this point, just this morning, well, let's finish. Pull this together here. Right, here's your linear equation. B is 70.78. Right. Once you get past the fraction, this boils down to, can you solve a linear, quadratic, any technique we've used so far. Just to be clear, I'm going to reiterate this 100 times this year. Why did I multiply by b minus 33 there? To get rid of the denominator. Okay, but why does multiplying get rid of division?
Because fractions are
There's something deeper than that even. Know the word? That's it. Multiplication and division are inverses. Okay. They counteract each other. Right? Why did I add? There was subtraction. They are inverses. Okay. It's not something that people really highlight. That word inverses scares people for some reason in general. So, but we will get to solving logarithms and exponentials. You probably never heard of, have you heard of logarithms? Okay, so logs and exponentials are inverses, so you have to use them to solve each other. Okay, so get used to hearing that word inverse when we solve equations, because it's going to help you a lot. Okay. All right, let's do something a little bit more fun. Yay! Okay, so you're going to run into equations such as this. It's really where the meat of this is. Okay.
Also with the A square on that side.
Here? You mean these two? Oh, sorry, I just killed the puppy dog. Hold on. No, you can't see how there's a minus sign? You can't. The only way you can cancel an a squared out here is if there's an a squared here and in both of these. It has to be in all the terms. Right. So, like this one here, we canceled 45 out by division because it was in both terms basically, right?
Yeah.
Okay. Here, a squared is not. So, the best thing for you to do is to break the denominators down to simplify the denominator, okay? And these questions take a lot of writing, right? So let's get used to that. We can factor this bottom, right? Right, difference of two squares. I don't think we're gonna have to bother with that. Okay, there are a couple ways to tackle this. You can find it, so we have added fractions, right? What do you do when you add fractions? You have to find a common denominator. Okay, that's one method, which we have to know that anyways. Okay, so we need to know the common denominator. Any ideas? What do we have here? A plus 1? Do you think we need one of those here?
Yeah.
Okay, so we're going to have a plus 1 here. So that's part of our common denominator. And that means we also have to multiply this, right? You okay with that? Some of you? Who's not okay with it? Okay. Pretty bold statement there, everybody. What else is there in the denominators? A minus 1, right? Do we have an a minus 1 here? Nope. Okay. If that has both of them, does that have an a minus 1? Nope. So you just found your common denominator. Here's what's nice about this method. Now the denominator can disappear. Because it doesn't matter. They're all the same, right?
Yeah.
So it doesn't, you don't have to worry about it anymore. Okay. So now we can eliminate the denominator, and rewrite our equation. Okay. Ooh. A little bit more friendly, but we still have some quadratics and cubics to deal with. So that's the part that you've probably never seen before in rational functions. Solving, getting rid of the denominator, now you can solve it with every other technique that you've ever learned. Okay. And we have to do a lot of multiplying here. So this is a polynomial, right? Got a really messy polynomial. We have to set polynomials equal to 0 to solve them, which means we have to combine all the like terms. Okay. So FOIL, here's where the difference of two squares is nice to know. Right. So this side we can have a cubed minus a plus a squared minus 5. That's as far as we can go there. And the right side. Multiply those together. So one in each of them. And then combine my terms, right? Those things, okay. You good? Let's do this algebra here. Long problems, huh?
Yeah.
Yeah, these are the longest ones you're going to see. I'll kind of hit you with the longest ones first. Now we need to set this equal to 0, so we're going to move everything one side or the other. It doesn't matter, but I try to leave a squared positive. Makes factoring easier. So I'm going to move everything to that side because it's already positive. So minus a minus 2. We get cancel. A squared minus 2a minus 3. And you can solve that, right?
Yeah.
By what method? When I tell you quadratics, it's your first thing you try. Yeah, factor. Can you factor that? I hope so. Somebody said that. Yep. So A is what? Negative 1 and 3. You okay with that? Like, no, I don't like to do it, which is fine. All right. You always have to check your answers in the original. Because one of those doesn't work.
Yeah?
Yeah. So, check answers. Alright, so if you look at your original, this is, what's nice about checking your answers is it usually doesn't give you, it's the denominator that causes problems. Okay. So if I plug -1 in, what's -1 squared? 1 minus 1 is, can you have 0 in a denominator? Alright, great. So -1 does not work. Okay. This gives us a denominator of 0. It's not a solution. Okay. And if you check 3, it in fact does work. So A equals 3. Okay. So always check, because you're going to get some invalid results. Because of the way we got rid of the denominator here, you're going to get some results that are probably invalid. You can. Not always going to be that easy, but possibility. Any questions on this? Yeah, long process, just take your time, step by step. Most of you are pretty good at writing your workout nicely and neatly. Don't get lost in the muck. Okay. Okay, that's a rational equation. It's actually really easy to solve. We hit this kind of thing in calculus like almost on a daily basis.
You just multiply both.
You can, yeah. What's 14 plus 1 times 0? 0, right? So that's an option. That's an easy solve, right? So t equals 5/3. Now, aside from showing that work, what do you know about fractions when they equal 0? The top has to equal 0, right? What if the bottom equals 0? No, it's undefined, right? Okay, so using that reasoning and logic, you can just go from here to here. Right? That's what I'd coach you to do because it's faster and easier. Right. So fraction equals 0, just worry about the top. Okay. I don't know if you're going to run into any of those. That's just, like I said, sometimes we run into those in calculus a lot. So, what else we could run into? Fractions. Oh yeah. Okay. I don't think you're not going to see this today, but we ran into a problem like this. That was one of our homework equations that we had to solve. So yeah, it's rational. So we had to find a common denominator, but it also includes a radical. We'll study radicals tomorrow. So, again, I'm just telling you, if you want to get ready for next year, the biggest thing you can do is learn how to solve equations. Okay. And it's equations of all kinds. You have the linears, the quadratics, rationals, square roots. We'll move into trigonometry. We're solving trigonometry equations. That's after Christmas break. No, that is in February. After break, we do sine, cosine, tangent with triangles, basically. So katoa. So the things you're gonna run into, so if you're gonna focus on anything this year, solve those equations, because it'll make your life a lot easier in calc. Okay. Any questions? Do you want me to show you how to do that one?
Yes.
What's the common denominator?
Square.
Yeah, root 1 minus x squared, right?
You can take me down.
I don't even want to know.
Multiply top and bottom. What is root 1 minus x squared times root 1 minus x squared?
1 minus x.
Minus x cubed, right? And then here's our common. What did I just tell you about denominators and zero? Solve that equation. It's just a lot easier than it looks. But you can find that common denominator if things drop out and you have your cubic, you're solving a cubic there, which ends up factorable and it falls out. So you would go and 0 equals 2x minus 2x cubed. You can factor an x out, then you have a difference of 2 squareds, and you get your algebra. Right? So x is factor 1 minus x, 1 plus x. So x is 0, negative 1, or 1. What's neat about this problem is it told us where the minimum and maximum were on the graph. Like we studied min-max last chapter, right? We did calculator-friendly stuff. This is an algebra method to get. Right. We're good. Make what 0? Everything? If everything was 0, nothing would exist. I don't think I understand your question. No, you said what if? Question.
What?
I guess we can check if you're that concerned about it. I'm not, so.
It did.
No, I don't.